data visualization using Matplotlib and Seaborn. So open your Jupyter notebook and start coding. First of all, import Matplotlib and Seaborn. Then read the CSV. We are taking into consideration iris data. If you want to have a general idea about the data set, then you can plot it using this function, kind is equals to area, and you will get this plot. You can see the hue as sepal length, sepal width, petal length, petal width. So it gives basically the total statistics of iris data set. If you want to see the frequency of the observation, you can plot it using the count plot. In this case, we are plotting the frequency of the three species in the iris data set. So you can see iris sendosa, iris versicolor, and iris virginica, and the corresponding count. So you can see total we have 50, 50, 50 of each species here. If you want to see the value counts in a pie chart, then you can do so using the pie function. So you can see 33.3% of iris setosa, iris virginica is 33.3%, and versicolor is also 33.3%. We can see that there are 50 samples each of all iris species in the data set. Joint plot is a Seaborn library specific and can be used to quickly visualize and analyze the data, the relationship between two variables, and describe their individual distribution on the same plot. So in order to draw a scatter plot with marginal histogram, you can use joint plot and give the column that you want to plot for. So I'm plotting for sepal length and sepal width. So sepal length, sepal width, and you can see the corresponding histograms here and the scatter over here. Replace the scatter plots and histograms with the density estimates. So you can do so by giving the kind is equals to KDE. So you will get this density estimates. Add regression. You can do so by giving the kind is equals to REG. Replace the scatter plot with a joint histogram using hexagonal bends. So you can give the kind is equals to hex. I'm plotting here for the two columns, sepal length and sepal width. Draw a scatter plot, then add a joint density estimate. That you can do by using joint plot and giving the columns that you want to plot for as x and y, and you can use a plot joint and sns.kd plot for adding a joint density estimate. Facet grid is basically a multi-plot grid for plotting conditional relationships. So you can see facet grid, the data, my data, then hue is equals to species here, and I'm mapping basically the sepal length and sepal width. So you can see this is iris setosa, and here you can see a lot of iris versicolor and iris virginica. Box plot is basically used to give a statistical summary of the feature being plotted. Top line represents the max value, top edge of the box is third quartile, middle edge represents the median, bottom edge represents the first quartile value, the bottommost line represents the minimum value of the feature, the height of the box is called as interquartile range, the black dots on the plot represent the outlier values in the data. So I'm plotting here for x equals to species and y is equals to petal width and hue is equals to species that you can see here. and the order is Iris setosa, Iris versicolor, and Iris virginica. If you want to draw a categorical scatter plot with non-overlapping points, then you can use swarm plot. So I'm specifying x equals to species, y is equals to petal length, and here you can see the swarm plot. Draw box plot by species. So you can specify box plot by species. So it will show you by species. So you can see the petal length, petal width, sepal length, sepal width for each species we have. Strip plot. Draw a scatter plot where one variable is categorical. There you can use strip plot. A strip plot can be drawn on its own, but it is also good a complement to a box or volume plot in cases where you want to show all observation along with some representation of the underlying distribution. So this is how you can draw a strip plot. You can give x, y, and data, and color is equals to blue. Hue I'm giving as the species. Then order is Iris setosa, versicolor, Iris virginica. Jitter is equals to true, edge equals to black. You can see the black underlining of the bubbles. Line width is equals to 1, size equals to 6, orient is equals to vertical, palette is equals to set 2. So you will get such plot. Then you can combine strip plot and box plot. So just use the box plot function here, then use the strip plot function here, and you can see that this is the box plot, and the small bubbles, this is the strip plot. Volume plot, it is used to visualize the distribution of data and its probability distribution. This chart is a combination of a box plot and a density plot that is rotated and placed on each side to show the distribution shape of the data. The thick black bar in the center represents the interquartile range. The thin black line extended from it represents 95% confidence intervals, and the white dot is the median. Box plots are limited in their display of the data as their visual simplicity tends to hide significant details about how values in the data are distributed. So you can plot a volume plot. So you specify x, y, and hue is equals to species, saturation 0.8, and palette is equals to set 3. So you'll get this, and for Iris setosa, versicolor, and virginica. Plot subplot for different columns in the data set. So if you want to plot different volume plots for different columns, then you can do so by specifying plt.subplot 2 to 1 means this one, then 2 to 2 is this, likewise. So it's row and column. Volume plot and is the same as the previous one. So I'm doing it once for sepal length, then for sepal width, then for petal length and petal width. And I'm giving hue as species, so you can see the color codings here. Okay, pair plot. A pair plot is also known as scatter plot, in which one variable in the same data row is matched with another variable's value. Shows how all variables can be paired with all the other variables. So you can do so by using pair plot function. Data, specify the data, kind is equals to scatter, hue is equals to species, and whether you want to drop the missing values or not. So drop NA is equals to true and palette is equals to winter. So you can see a beautiful pair plot here which you can analyze. Heat map is used to find out the correlation between different features in the data set. High positive or high negative value shows that the features have high correlation. This helps us to select the parameters for machine learning. This is a very important plot basically, and for machine learning projects you might have seen a lot of people use heat map. So You can do so by using the heat map function. So here you specify all the values, and you'll get to know like how sepal width is related to petal width, how petal length is related to sepal width, etc. And this is the parameter. Next is the distribution plot. The distribution plot is suitable for comparing range and distribution for groups of numerical data. Data is plotted as value points along an axis. You can choose to display only the value points to see the distribution of values, a bounding box to see the range of values, or a combination of both as shown here. The distribution plot is not relevant for detailed analysis of the data, as it details with summary of the data distribution. So you can see here I'm plotting the histogram. So I'm giving bins equals to 10, grid equals to true, and you can see the result here. And now later on I'm plotting the histogram by species. So you can see this is by species, and this is by the features: petal length, petal width, sepal length, sepal width. LM plot data and regression model fits across a phase grid. This function combines reg plot and facet grid. It is intended as a convenient interface to fit regression models across conditional subsets of a data set. You can use LM plot and give x equals to whatever column you want, and y, and data equals to your data, and you can give hue as species, markers is equals to whatever marker you want, O or a line or something, palette is equals to winter. So you can see this LM plot here, which is basically combining reg plot and facet grid. Now the facet grid, you can plot facet grid using facet grid function here. So you can specify your variables here, and you can see a beautiful facet grid here. Next is Andrews curve, which is very interesting. Andrews curve in data visualization, and Andrews plot or Andrews curve is a way to visualize structure in high dimensional data. It is basically a roll down non-integer version of the Kent Kuwait radar M chart, or a smoothened version of a parallel coordinate plot. In pandas, use Andrews plot to plot and visualize data structure. Each multivariate observation is transformed into a curve and represents the coefficient of a Fourier series. This is useful for detecting outliers in time series data. Use color map to change the color of the curves. So you can see I have specified my iris data here. I'm doing it for species, and color map is equals to rainbow. So you'll get beautiful Andrews curve here. Parallel coordinate plot. This type of visualization is used for plotting multivariate numerical data. Parallel coordinates plots are ideal for comparing many variables together and seeing the relationship between them. For example, if you had to compare an array of products with the same attributes, for example, comparing computers or car specs across different models. So this is for our different species here. So you can import from pandas.plotting the parallel coordinates, and then you can specify your values. Radwis plot is a multivariate data visualization algorithm that plots each feature dimension uniformly around the circumference of a circle, then plots points on the interior of the circle such that the point normalizes its value on the axis from the center to each arc. So you can do so by using Radwis. So you specify your data here, your species, and the color you can give. So you can see my iris versicolor and iris virginica both are overlapping here. Factor point is informative when we have multiple groups to compare. So I'm comparing species and sepal length. So you can see for iris setosa, what do you have? It's a sepal length. So this will basically give us a comparison. Box and plot is basically an enhanced box plot for large data sets. You can plot it using box and plot and just giving the columns as species and sepal length, whatever you want to compare, and giving hue is equals to species. You can see here, and palette equals to set3. Okay, so you'll get this plot. Residual plot, the most useful way to plot the residuals though is with your predicted values on the x-axis and your residual on the y-axis. The distance from the line at 0 is how bad the prediction was for that value. So you can use the function residual plot here and give the values here, and you'll get this residual plot. It's one of the most useful plot basically. Donut plot. A donut plot is chart. A plot is basically a pie chart with an area of center cutout. So you can give your features name here, whatever columns that you have here. Then feature size. You can calculate the length of uh, each features that you have, and you can you plot the circle and use a pi function and give the values here, and that's how you can get number of each features for each columns that we have. Right now we have equal features in each column, so that's how it's properly uniformly distributed. If you want to create a KD plot of sepal length versus sepal width for setosa species of a flower, you can do so by using KD plot. KD plot is used to fit and plot a univariate or bivariate kernel density estimate. So you can do so by using KD plot, and for a particular species like Iris setosa I'm doing. Yeah, so you can compare the sepal length and sepal width for Iris setosa, and yeah. Venn diagram, as you know, a Venn diagram is basically a logic diagram. It's a diagram that shows all possible logical relation between a finite collection of different sets. Each set is represented by a circle. The circle size represents the importance of the group. The groups are usually overlapping. The size of the overlap represents the intersection between both the groups. So you can see between sepal length and sepal width, you can see these many data sets which are overlapping. So you can specify sepal length, sepal width, petal width, and I'm plotting this one for sepal length and sepal width. Likewise, you can do it for petal length and petal width. Yeah, so that's it from my side for the data visualization. Thanks for watching, and stay tuned. Subscribe to our channel to know more such videos. Next would be data visualization in 2D and 3D. So thank you.